Welcome back, guys. So now we're looking at y equals x minus h all squared plus k. We've added another component again, and we're just going to look at what changes it makes to the equation or to the parabola. Again, just a recap, we've looked at how we put a coefficient of x squared, how that changes, positive or negative. We've looked at putting a constant c and what happens there, and we've identified that is your vertical translation. When we manipulate a, it's the dilation of the parabola. And then recently we looked at x minus h all squared, which is a perfect square form. And this is your horizontal translation. Let's bring this back here. So horizontal translation, so it moves it left or right. It's also the axis of symmetry, and it is also the x coordinate, x value of your turning point. Okay, so now we're going to add the value k to the whole mix of things, and we'll see what that does. So let's get into it. So what do we have here again? Y equals x squared, and we have our traditional parabola just as our base comparison. I've got the plus 2 there, so we've established from the previous video that it's going to move 2 units to the left. Anything that is a negative h is going to move to the right. But what does the 3 do? Well, we'll see. So what we can have a look at in comparison, not only has it moved 2 units to the left, but it's also moved 3 units up. Okay, and this point here, which my cursor is just being a little bit silly at the moment. Over here we can see that right here is our turning point at -2 and 3. Okay, if we were to highlight the next one, -2 and -3, not only has it moved 2 units to the right, but it's moved 3 units down. Okay, so here we have a turning point of 2 and -3. The same thing will apply when we have a negative parabola. So this is identifying that it's going to be inverted. This is obviously moving 3 units to the left, but what we can identify that this is now moving 2 units up. Okay, so let's have a look at this. So it is upside down, so that's the first thing that we've ticked off. It has moved 3 units to the left, which is the second thing that we predicted. And the third thing, it has moved 2 units up, making our turning point at -3 and 2. Last example, we have a negative parabola once again, but in this case it has moved 3 units to the right and 2 units down. So what does that look like? It is inverted, correct? It's moved 3 units to the right and it's moved 2 units down, and our parabola's turning point, it's a maximum turning point, is at 3 and -2. Okay, now I don't know if you've noticed the pattern here, is that these two values, okay, so -2, +3, is going to be your turning point for the parabola. We can quickly look at this equation. +2 and -3 is going to be your turning point for the black one here. The next one, -3 and +2 is the turning point for this parabola in the green. And then lastly, we have +3 and -2 being the turning point for this darker red parabola over here. Okay, so what I want to get to, I guess you understanding, is that this formation here is actually what we call turning point form. Okay, so I'll just put turning point form, and your turning point when you're looking at this particular equation is going to be identified as negative h and k. Now, the reason why I've put negative h, we've identified that it's always going to be the the opposite polarity of whatever h is. So if we had y is equal to x plus, let's choose different numbers, x plus 7 all squared minus 3, our turning point is going to be at negative 7 minus 3. So the minus 3 stays the same, but the 7 will be flipped. Okay, so putting that into practice, I've got a few examples here with question 1. Okay, so turning point for A is going to be positive 1 and 1. For B, we're looking at negative 2 and negative 1 as our turning point. For C, we have 3 and positive 2 as our turning point. For D, it's going to be the reverse of positive 3, so minus 3 and negative 2. That stays the same. For E, we have a negative 2 and a negative 1. And then for F, we have a positive 1 and a 2 as our turning point. And in reverse, we can also apply this by looking at the graph and working out what the turning point is, therefore identifying the equation. What we have here is we've got a positive 2 and a positive 2. So if we just wrote out the turning points for each of these, we have 2 and negative 1. In this case, we have negative 2 and negative 1. And in this case here, we have 3 and 4. We have negative 1 and minus 4. And then the last one, we have 1 and minus 4. Okay, so we've written down our turning points, and it's a matter of just using those numbers and putting into our equation. First thing, we know that A, C, E, and F are positive parabolas, okay? They're upright. So for A, we could say that it's y is equal to x minus 2 all squared plus 2, okay? So remember the x value is our h, and it's going to be the opposite polarity. Let's look at C. Y is equal to x plus 2 all squared minus 1. For E, we have y is equal to x plus 1 all squared minus 4. And then for F, we have y is equal to x plus 1 minus 4. Okay, so lastly with our with B, it is a negative parabola. So B is going to be y is equal to minus x minus 2 all squared minus 1. And then for D, we're going to have y is equal to minus x minus 3 all squared plus 4 as our equations. All right. Going to just cover a few other elements in regards to this turning point form and let you to get into some practice. So before we get into some problem solving questions, I want to get you to think about the Y-intercept again. Okay, so remember the Y-intercept is found when x equals 0. Now, The problem and the most common issue or mistake that people make is that they think that this value is the y-intercept, because they're thinking that it's a constant. It's not, okay? It's in a very different formation to y equals ax squared plus bx plus c, and therefore c is your y-intercept, because when you make x 0, it cancels out these two terms, leaving this term on its own. But in this case, when it's in turning point form, it does not apply that. The same rule does not apply. So you want to make sure that use the same logic that the y-intercept is found when x is made 0. So when x is 0, we have 1 squared, which is just 1, plus 1 is equal to 2. So our y-intercept for this equation is actually 2, not positive 1. And if we applied the same rule with a different equation, let's try C. So y is equal to x minus 3 all squared plus 2. Our turning point, as we just said before, is 3 and 2. Our y-intercept, okay, is found when x equals 0. So 0 minus 3 all squared plus 2. 3 minus 3 squared is 9, plus 2 is equal to 11. So our y-intercept is actually 11 in this case. Okay, so that's just something I want you to really highlight, that it's not k, the k value is not the y-intercept, which is why it's not the letter C, it's actually the letter K, because it is in turning point form, and it's relating to the turning point, not the y-intercept. Hopefully that helps you, just to avoid making that error that many people do make. So I want to finish off with this problem solving question. Nikki wanted to keep a carnivorous plant. So after school, she recorded the temperature on her windowsill for 8 hours every day for several months. That's a lot of work there. One summer evening, the temperature followed the relationship of that formula. T represents temperature and H represent the hours after 4 p.m. Okay, because I guess this is something that she does after school. Find the temperature on the windowsill at 4 p.m. So if time is measured in hours for H, okay, then H, we want to know what, I guess, the temperature, what is T when H is equal to 4. So simply let's just substitute that into our equation. So T is equal to 4 minus 5 all squared plus 15. So 4 minus 5 is just minus 1. And minus 1 all squared is 1, plus 15 is equal to 16 degrees Celsius. Okay, so that's the first answer, 16 degrees Celsius. Show that the minimum temperature reached during the 8-hour period is 15 degrees. Okay, so the key word is minimum, and what we can see from our equation that we're given, that obviously the temperature is going to start from the top, it's going to hit rock bottom before increasing in temperature again over time. Okay, so the turning point is basically at so remember that it's going to be the reverse of that, so that means it's 5 and 15. So that's going to be our turn. The 5 represents the time, okay, in hours, and then 15 is representing the temperature in Celsius degrees. Okay, so the next question, part C, find the number of hours it took for the windowsill to reach the minimum temperature. Well, we can see that it's going to be 5 hours. So we'll put 5 hours here. And then sketch the graph of the relationship between the temperature and the number of hours after the recording began. Okay, so there's a few things that we already know, and I'm going to sketch this graph. We already know that our turning point is at 5:15. So if I just went, say, 5, 10, 15, 20, 5, no, let's go 5, 10, 15, 20, 25, 30, 35, 40. That's probably a better scale. And so your scale is really important to make sure that, I guess, it's consistent. So I've got 5 there, 5, 10, 15, 20, 25, 30, 35, 40. The worst thing is that you draw a graph that's either not to scale or not really reflecting the information provided accurately. Okay, so 5:15. So 5:15, we're looking at a turning point over here. The other aspect that we also need to work out is our Y-intercept. Or in this case, we've got our temperature, okay, and we've got our time in H. So we're wanting to work out what T is when H is equal to 0, okay. So what we'll have here is that T is equal to 0 minus 5 all squared plus 15. Minus 5 squared is 25 plus 15 is equal to 40. So at the very beginning, when the recording has started, the time or the temperature taken is 40 degrees Celsius. So it starts here up on the top. Then it goes down to the bottom over here. And for, say, the 8 hours, because that is how long it's going for, we're going to see what happens at 8 hours. So we're going to substitute the value of 8 into H. Okay, so we've got T is equal to 8 minus 5 all squared plus 15. 8 minus 5 is 3. 3 squared is 9. So 9 plus 15 is equal to 24. So at the 8-hour mark, which is around here, we're looking at 24. So I'm just going to put it around there. Okay, so this is the 8-hour mark. This is the minimum temperature. And this is the start of the recording. And so if we were to sketch that, we end up having something like that. Okay, within that time frame. So that is then the answer to part D of this question. If you have anything that you'd like me to revise, clarify, whether it's this part or something taught in the past, please let me know. Otherwise, I'll see you in the next video.